All right, hey folks, can you hear me? Awesome. Welcome to Secure Remote Connectivity on AWS. My name is Tom Adamski. I'm a Principal Solution Architect, and I focus on anything to do with networking. I'm joined today by Shovan Das. He's a Principal Product Manager, focusing on AWS connectivity solutions, remote connectivity solutions. And our guest, Juan Suarez from Avalon Healthcare Solutions, is going to talk about their specific use case. Before we dive into the agenda, I want to set the scene with differentiation between corporate connectivity and remote connectivity. When we're talking about corporate connectivity, we often think about connecting to different networks, whether they're on-premise, data centers, branches, through things like VPN, MPLS, fiber connectivity. And then on the other side of that equation, we have remote connectivity. That's where we have a user somewhere out on the internet, and we need to give them access to our private resources, either a private network or specific applications within that network. So the right-hand side is what we'll be focusing on today for the rest of the session. On the agenda, we'll talk about remote access considerations, so what you should think about when you're deciding on a remote access solution. And then we'll talk about different use cases. We're going to talk about a network use case, when you're giving access to a whole network, and then application access use cases, split into SSH RDP, as well as HTTPS. And with the HTTPS one, we'll have an example customer story from Juan. Right, so what do you need to consider when you're deciding on a remote access connectivity solution? So first of all, you need to figure out what resources you're giving access to, where those resources live. You also need to figure out what level of trust and validation do you require for your users accessing those resources. And then finally, how do you audit access? You need to audit every single request, or is it enough to audit just the fact that someone accessed the network? And this is just the tip of the iceberg. There's many other things that you might need to consider. And things that can help you figure out what you need to consider are cybersecurity frameworks. So things like NIST, ISO 27001, CIS. So all of those frameworks would have some guidance on running a risk assessment and figuring out the risks within your environment and what you're concerned about, and then giving you some kind of mitigation plan. And you can use that mitigation plan to decide on your connectivity solutions. Now, I already mentioned we're going to have these two different use cases, network access and application layer access. And I want to explain what that means. And for that, I'm going to use a TCP IP model. If you're familiar with networking, you're probably familiar with this model, as well as with a little bit more complicated OSR model with 7 layers. This is a simpler version of that. And we use this model to figure out the different layers that are participating in forwarding network traffic between nodes within our environment. So from the bottom, we have network access layer. This is physical connectivity, fiber, and then the protocols running on top like Ethernet. Then we have the network layer. That's the IP address layer, where we have IPv4, IPv6 addresses. On top of that, we then have TCP, setting up our connections, as well as UDP. And then finally, the actual application that's being forwarded over the network. So HTTP, FTP, SSH, and so on. And today, the two different use cases are going to be network access, so giving access to remote user to effectively your IP addresses, and then separate use cases around application layer access, so granular access to a particular application. And if we divide some of the AWS services that we have into those categories, for network level access, we're going to talk about AWS Client VPN. For the application use case with SSH and RDP, we'll talk about Amazon EC2 Instance Connect, as well as Session Manager, which is part of Systems Manager. And then for application layer, we talk about verified access, AWS verified access, AVA. Right, so let's start with network layer access. So for that, we're going to talk about Client VPN, which is a managed remote access solution from AWS that allows you to automatically scale with your demand. You don't have to deploy your own remote access servers. Everything is managed for you. You have the ability to apply granular controls for that access. But just remember that this is a network access solution, so those controls will be based around IP addresses. And then finally, something that applies to all of the services we're going to talk about, the fact that you can access your resources from anywhere. And with Client VPN, because it's a network level access, you can pretty much access any resources on that network. All right, let's do some architectures. So we'll start off with a high level overview, high-level architecture, and then we'll start breaking down each component separately. So at a high level, we have a region here, an AWS region. Inside that, we have your private environment, a VPC. And inside that VPC, we have some kind of resource. This could be an EC2 instance, your virtual machine. This could be a database. This could be a load balancer. This could be a container. It really doesn't matter. As long as it has an IP address, it applies. And then if we want to allow our remote user to have access to those resources, we need to provision an AWS client VPN endpoint and then associate that endpoint with our VPC. We then have to make sure that the user has appropriate software on the machine to be able to establish a TLS connection to the client VPN endpoint, at which point we'll do authentication and authorization to validate if the user is permitted to access the resources that they're going to. And then if they're permitted, we'll pass the traffic along to the destination. Okay, so let's zoom into some of these components. So let's start with the remote user. I already mentioned the remote user has to run a client VPN software, and AWS provides you with that software that you can install on Windows, Mac, and Linux machine. You can also use open source, OpenVPN software to establish a VPN, but it will have limited functionality. So check out the documentation what the differences are. And then from a connectivity point of view, client VPN supports both full tunnel as well as split tunnel. So with full tunnel, what we're saying is any traffic to any destination should go over the tunnel first, regardless of where it's going. With a split tunnel, we're defining a specific IP address block that should go over the TLS tunnel, and everything else, connectivity to other destinations, will just use the remote user's local network connectivity. Now, if you have multiple users connecting at the same time, there's also an option to enable client-to-client flow directly without you having to go through the VPC. So that's a fairly recent feature as well. Okay, let's zoom in on the authentication and authorization now. And all of the options I'm going to mention, they're interchangeable, so you can decide which options you're going to use. And we'll start off with mutual TLS. So you can provide a client certificate to your remote user. As long as that certificate is valid, the client VPN will authenticate the user. You can use it on its own, or you can combine it with other authentication methods. So you can use Active Directory or SAML to make your policy decisions. And then with those two options, Active Directory and SAML, that's where you have those granular authorization rules, where you can say if the user is part of a particular group, in my example here, it's engineering group, they're going to be allowed to get to a particular destination. And the destination here is just an individual IP address, but this could be a whole network. An additional function that Client VPN has is Lambda Connection Handler. And it's a very interesting feature. Lambda is a serverless environment where you can bring your own code, and you can integrate that with Client VPN endpoint. So after the user authenticates, we will send a bunch of information to a predefined Lambda function that you control. And you can do whatever you want with that information. So here is an example of what the Lambda would see. And you could, for example, pull out the public IP address of the remote user, and then check that against a geodatabase to see what country that user is coming from, and then still block that user even if they successfully authenticated. So it's like an extra gate that you can optionally add to your client VPN. Okay, let's look at the final piece. So client VPN endpoint association with the VPC. And we do recommend that you associate it with more than one availability zone for high availability. And the way the association happens is that you decide on which subnets you're going to associate with. And in those subnets, the client VPN will provision elastic network interfaces, ENIs. Think about them as just virtual NICs. And then all the traffic that's coming from the remote users, regardless of what IP address you assigned to those remote users, will be source address NATed, effectively translated to the IP address of those network interfaces. A side benefit of that is now you can have a security group B in this example, wrapped around those network interfaces, and then you can reference that security group on resources already in the VPC. So on my security group A, I'm saying I'm allowing HTTP traffic, but only from my security group B, which would identify any traffic coming in from the client VPN endpoint. Another benefit of doing the NATing is that we can get the traffic to any destination as long as we can route to that destination. So not just the local VPC, but we can connect to a bunch of other destinations through other networking constructs. So other VPCs through Transit Gateway, Cloud One, peering connection, as well as private link endpoints. We can also connect to resources on-premise. So we can connect to your corporate data center as long as there's a network connectivity for something like site-to-site VPN or Direct Connect, or even allow connectivity to the internet. And if you want, you can deploy an additional firewalling in the path. So I'm showing an example with AWS Network Firewall, but you can also use third-party vendors, deploy them in the path, and then traffic going to those different destinations can be inspected before getting there. And there's an arrow missing over the peering connection on purpose. That's something that's not supported. All right, from a logging perspective, Client VPN allows you to log information to CloudWatch. And if we have a look at an example of a log entry, it actually looks very similar to the information we're sending to that Lambda connection handler. So it's going to have a lot of information about the user connecting. This is an example of a failure. Someone failed to connect because their authentication failed. Okay. So moving on to applications, so more granular connectivity to where you're actually accessing a specific application layer rather than just giving access to the network. And we're going to start with SSH and with RDP. And I had to select one of the two. We didn't have enough time to cover both. So I picked SSH. Just assume that RDP is also supported. And we can chat afterwards if you want to dive deeper into the RDP side. OK, so you might have seen this before. When you connect to an instance in the console, you would see the screen telling you that there's a bunch of different options that you have to connect to your EC2 instance. And we'll talk about all the first three. I, again, didn't have enough time to talk about the EC2 serial console, but just know that this is an out-of-bound access to your EC2 instance. So even if you lock yourself out, you mess up security groups, knuckles, whatever, you can't get to the instance anymore for some reason, you can always use EC2 serial console as an out-of-bound backup access. OK, so we'll start off with the basics. We'll go over how SSH access looks like. We'll talk about some of the challenges for SSH access, and then how those challenges might be solved by the two solutions we have. So here we have an EC2 instance and a remote user that will need to SSH to our instance. So there's a number of things we need to do to make this work. First of all, we have to assign a public IP address, or elastic IP address, to our instance. We need to create an internet gateway that allows access to and from the internet. We also have to set up routing. I'm not showing you the route tables, but just know that the route tables are there, and you have to make sure they're correct. And then we have to have a security group around our instance, allowing traffic over SSH from a particular IP address. So I'm saying here from the remote user, as long as we know the IP address of the remote user, but if we don't know what that is, we might have to allow it from anywhere on the internet. And then SSH uses PKI, so there's going to be a private and public key that have to be a pair. Private key is always hidden, and the user only knows about it. Public key would go onto the instance. And as long as they match, the user will be able to establish the SSH session. So here's a CLI access example. The user will run an SSH command, specify the private key that's been assigned to them, specify their username, and then the IP address of the destination instance they're connecting to. And if all is good, they'll be able to set up an SSH session to our destination. So what are some of the challenges with this? First of all, the public and private key management. I've shown you a single user, single instance. That's a single key pair. Imagine you have hundreds of users, hundreds of instances. You have a constant management of those public and private keys. And on top of that, you should be rotating them on a regular basis. So actually, the rotation piece, that's actually the hardest part of all of it. Second of all, you have to set up a public path to and from the internet. So maybe you want your VPC to be completely isolated, but to make SSH work, you have to have an internet gateway. You have to have a public IP address. And then from a security group perspective, you have to have that security group allowing traffic potentially from anywhere in the world. So we're going to have a look at two solutions, Amazon EC2 Instance Connect, and then part of Systems Manager, Sessions Manager. OK. Let's start with EC2 Instance Connect. And there's always going to be two options, one with an internet gateway, and then we also have an option without an internet gateway. I'm going to start on the one with internet gateway. So bare bones, EC2 Instance Connect. We still have an EC2 instance. We still have elastic IP address. We still have an internet gateway. And we still have a security group that allows access from the remote user. Now, but this time, instead of talking directly to the EC2 instance, we're going to use the EC2 Instance Connect service, and that will talk to our instance over the public internet, and then the user is going to talk to our EC2 Instance Connect service. So the user will be using AWS CLI, so you wouldn't be using your SSH agent. You'll be using AWS CLI to run EC2 Instance Connect commands, and you're saying here that you want to SSH into this particular instance ID. Now, because it's using AWS CLI, we have the ability to check if you have the appropriate policy to be able to connect to that instance. So there's a way for us to validate using identity and access management outside of the OS if you're actually permitted to do this SSH connection. And then on the fly, if you're permitted, we're going to generate temporary public and private keys. So you no longer have to worry about management of those public and private keys. They're going to be generated on the fly, and they're only going to be temporary. Again, if everything works correctly, the user will be able to set up a session using TLS, actually, if you notice there, to the EC2 Instance Connect, and within that session, they'll establish an SSH session. EC2 Instance Connect also supports browser access. So if you want to use your browser, that's also available. Just make sure that you update the security group to allow an additional range. Okay. If you want to zoom in, and have a quick glimpse, don't worry about all the details in there, but this is just a quick glimpse on how a policy might look like for this access. So we're saying here that we're allowing anyone with this policy to connect to any instance, so it's instance /* as long as it has a specific tag value. So our user will be able to connect to an instance with a particular tag. And you can configure these policies however you want, so this is just a single example. Now, if we want to get rid of the internet gateway, we can do that by using EC2 Instance Connect endpoints. So instead of using an internet gateway, we'll have a private way to connect to the EC2 Instance Connect service, and that's going to be an endpoint inside the VPC. You notice that the endpoint has a security group. So traffic is going to go from the service to the endpoint privately, and then from the endpoint privately to our EC2 instance. And then because the endpoint has a security group, we can again reference that security group on our instance security group to say, I'm only allowing SSH as long as traffic comes in for this EC2 Instance Connect endpoint. Connectivity looks the same. If you're using the CLI, we will automatically detect that the endpoint exists, so you don't have to specify anything different. You just say, I want to connect to an instance. We'll check the policy as long as you allow it. We'll create the keys on the fly, and then you'll be able to set up the session to your instance. And then same goes for the browser. From the endpoint perspective, there's a couple of things that you can set up here. So you can set up and decide if you want to do IP preservation or not. So if you disable IP preservation, any traffic coming to your EC2 instance will look as if it's coming from the IP address of the endpoint. If you enable IP preservation, we will actually preserve the real client IP address, the public IP address of the remote user, all the way to the EC2 instance. So you'll be able to see that in the logs. Okay, so that was EC2 Instance Connect. I want to switch to Sessions Manager, which is part of the Systems Manager. So Systems Manager is a suite of services that you might already be using or you would be using for orchestration and management of your EC2 instances, as well as virtual machines on-premise, as well as even other cloud providers. So you can do things like send commands, or like in our example, we're going to talk about Sessions Manager, which is specifically used for remote access. Now, for Systems Manager, you do have to deploy an agent on your EC2 instance or any virtual machine that you want to use it with. So that's something that you need to be aware of. Although with most EC2 instances that you would deploy, the agent is pre-installed automatically, the Amazon Linux ones. Okay, so let's have a look at the architecture for Sessions Manager. We again have our EC2 instance, we have our internet gateway, we have our remote user, and this time we're going to be talking to Sessions Manager. And the interesting thing here is that it's not the Sessions Manager talking to the EC2 instance. It's the EC2 instance that will do an outbound connection to the Session Manager. And to be able to do that outbound connection, it needs to have the right permissions, and that's done through assigning a Systems Manager role, SSM role. That role just gives permissions to the instance to be able to connect to the Session Manager service, and as long as there's a network path, so in this case, it's a public network path, it will need an internet gateway, it will need a public IP address to connect to the Session Manager service. And then so from a security group perspective, there's actually quite an interesting outcome here because the EC2 instance is doing an outbound connection, we don't need any inbound rules. So our inbound rules can be completely locked down. We don't have to have a single one, and SSH is still going to work. Okay, so our remote user will also use AWS CLI to connect, this time use AWS SSM to start a session to a target instance. We can again check them against the identity and access management policy to make sure, are they actually allowed to connect to that instance? And then as long as they are, the TLS session is established, the keys are provisioned, all of that. This approach also supports browser access, so very similar to EC2 Instance Connect, we have both options supported. Now, if we don't want to have an internet gateway, we can also use endpoints in this scenario. This time, we would use a systems manager endpoint to allow the EC2 instance to talk to the session manager service completely privately without having to use an internet gateway, without having to use a public IP address. But everything else still stays the same. If we have a look at how the policy looks like, again, don't worry about it being very complex. I know this is a 200-level session, but this is just a glimpse of what you might be able to do. In this scenario, we're saying we're allowing whoever has this policy to start an SSM session to a particular instance, and there's one extra option I've added here, as it's an optional thing that you can do, is you can specify an SSM document. So SSM document is a set of instructions that will be applied at the connection time to the user connecting to the instance. So here, in this example SSM document, we're saying, as soon as someone connects, there's going to be a specific log path we're interested in, and we want to immediately start tailing, or effectively looking at what's appearing in that log path. So let's look at an example how a remote user would use the policy. They would have to modify their SSM command to specify that they're using an SSM document, and you can enforce the usage of the document or not. So if you always want everybody to use the document and someone doesn't include it, you can block access using just IAM. So everything is correct. So user establishes a session, and then we immediately run the information in the policy, in that SSM document, and the user is going to start seeing the logs entries appearing in the log. Sessions Manager also supports session activity logging. So you can send those logs either to a storage service or CloudWatch. And here is an example of a particular entry. So that's, we can see that someone connected to an instance. We can see what role whoever connected to it used, and then what user they were running as. And then below, you can see the commands they've run. So they decided to ping a public IP address, and they got a successful response. So anything they would do in the console, you can log and send to CloudWatch or S3. Okay, so we talked about EC2 Instance Connect, and we talked about Sessions Manager. There are some similarities here. So first of all, if you don't want to use an agent, if you don't already have an agent, then EC2 Instance Connect is the way to go. It's a simple approach. You connect and you get access to any EC2 instance as long as it's running Linux on Windows. With Session Manager, if you do need an agent, but if you already have that agent, you can connect to more OSs. We're adding macOS, as well as you can connect to things on AWS, like EC2, but also resources in your on-premise environment. And with Session Manager, as you remember, you don't have to allow any inbound SSH access because the connection from the instance is only outbound. Finally, both allow you to not worry about managing SSH keys, and both support browser and CLI access and effectively checking identity against identity access management. Okay, so I want to move on to the application access use case, and Shovan's going to dive into that.
Thanks, Tom. Thanks for talking about access to network and access to EC2 instance. And I will talk more about access to HTTP application. I'm Shovan Das. I'm a product manager in EC2 VPC team, and I manage client VPN and the next product, which is AWS Verified Access. We also call it AVA, so you might hear me saying AVA. So as Tom said in the beginning, when you consider access to a resource, you have to consider three things. First, what's the resource? In this case, it is HTTP application. The second thing is that what level of trust or verification you need to do for a user to allow them to access the application or resource. And third thing is that what is your audit criteria, right? So we will look at HTTP application through these lenses. These HTTP applications are developed by your engineering team using AWS resources like EC2, VPC, and they are HTTP applications such as IT help desk, which each and every employee staff needs to access. Then there are sensitive financial application, which only your finance team or executive needs to access. So you can see there is a wide spectrum of these applications, and as a security administrator, you need to have that fine-grained control who can access the application under what conditions. And second thing is that these applications can be hundreds and even thousands. So you want something which is easy to manage, which is easy to audit. And on the other side, you have users. So the users, since they are HTTP applications, they just want to open their laptops. They want to type the application's DNS name, domain name on their web browser and want to access the application. So they want it as simple as possible. And they want to access it from anywhere. For example, right now you're in Vegas, but you want to connect to your applications and then want to use it for your productivity, right? So taking all this feedback, we developed AWS Verified Access or AVA, and we released it last year at reInvent. Just to recap, it does three things, right? The first thing it does, it allows your users, employees, staffs to connect to their applications from anywhere. So it gives them mobility, it improves their productivity. The second thing is that AWS Verified Access is built on zero trust principles. So it allows you to have a better security posture, and it allows you to have that fine-grained security control, who can access what application under what condition. And third thing is that it's quite simple to manage, because you just need one single verified access for all your applications, no matter what VPC, what account they are in. And you can just have a single set of policies with identity, with device postures to govern the access. And we'll touch upon that. We'll touch how easy it is to manage. Since we said that it is built on AWS verified zero trust principles, which can mean different things to different people. So I just want to say what is our zero trust principles. The first thing is that we say that you should use, apart from networking, you should also use non-networking signals such as identity and device posture. And it also emphasizes that more number of signals you use, the better the security posture is, the better the trust is before allowing the access. And second thing it emphasizes is that continuous verification process. For example, let's say I want to access application 1, verified access will run the policy, will check my identity, device posture, and then allow me access to the application. Moment later, I want to access application 2, it will revalidate me, it will re-verify against the policy that my administrator has written. Now I want to again access application 1, even though few seconds earlier or few minutes earlier, I was in the application, but still the verification process will run in case something has changed. So that's the AWS Zero Trust principle, use multiple signals, use non-networking signals, do the continuous verification, which gives you better security posture. And verified access is built on that. So Zero Trust is nothing new. Our customers have been implementing it for a while, but it can get complicated and cumbersome. And verified access solves that, right? So if you look, you have applications, these HTTP applications, hundreds and thousands of them. Your developers are building them. These developers, they're integrating with their identity, with your identity team, with your identity service, and then writing policy who can sign on to this application. Then you have networking team who are managing VPN policies who can onboard to the application, to the network. Then with the help of IT team, you are deciding under what condition a device is compliant and when they can join the network. So at the end of the day, you have at least 3 sets of policies managed by 3 sets of teams. And in case you want to roll out a new application or you want to make a policy change, it can take days and weeks, right? So with verified access, what we have seen is that it's a single gateway for all your applications. You write a single set of policies, so the control goes to the security administrator. They define who, under what condition can access the application. And we have seen customers rolling out new application or making policy changes just in a matter of minutes. They come up with a new application, put it behind AVA, change policies, and within few minutes it is ready for their users and staffs. Zooming in on verified access, so what happens is that the moment your users open their laptop and type the web domain name of the application on their browser, all HTTP request comes to this verified access gateway. Here we allow you to write policies, and we pull data from third-party providers, identity and device posture. With that data, with your policies, we decide that whether the user can connect to the application. If the policy says yes, users can connect, so then we connect the application to your, we connect the request to your application. These policies are fine-grained as we talked, so you can say that any employee, any staff can access IT help desk. But to access financial application, the user must be from the finance team, must have a compliant device, must have malware running, must have certain OS version running, all those things. Then only they can access the application. The second thing which Tom talked about is audit criteria, right? So verified access logs each and every application request, whether allowed or whether denied. This itself is quite valuable for our customers because now they can go and use that information to either troubleshoot or do compliance check, audit checks, or just in case they want to investigate some security incidences, right? So they can go to the log and find all those things out. And the third thing is that verified access, it aims to build an open ecosystem. So we are integrating with third-party providers, identity provider, device posture providers, so that to move to a zero trust architecture, you don't have to change your existing security or existing IT services. So we want to make it as simple as possible to migrate to a zero trust architecture. And talking about partners, so here are our partners. You will see we have identity partners, we have device partners, we have partners who are consuming those logs and giving you the rich insights. And we are constantly working to increase this partner system, right? So that you don't have to change anything to migrate to verified access. And in case one of your services is not listed here and you want us to have a chat with the partners, we are happy to do that. So just let us know and we can chat with them and onboard them. We talked about how simple it is to manage. So let's see. The first thing is that you create a verified access, and this is created by your security administrator or network administrator, the central administrator team. But this verified access will work for all your applications which are managed by different teams, different developers, different VPCs, different accounts. And you connect, then the second step is that you connect to your identity provider, device management provider. Then with the help of your developers, you onboard the applications into verified access, and then you write policies, and once you write policy, the application is available to all your users. So all your employees, thousands of them, they can just type the DNS name, domain name, and access the application. And the policy will decide whether they should be allowed or not. So let's see how adding an application to verified access looks like, right? So these applications, as we talked, they are in a VPC. This VPC is owned by your developers and in a different account, right? And these applications, they are always front-ended by a load balancer, such as application load balancer, network load balancer. In some cases, we have seen just elastic network interface. But what happens is that this verified access is shareable. So it is shared by a resource access manager, RAM. And your security administrator shares this with your developer accounts. Then they can onboard their ALBs or NLBs to verified access. When they onboard, what happens is that verified access gives them a DNS name. That's the endpoint where the user request is routed. But from your perspective as an administrator, you can just CNAME, you can map the endpoint domain name to your application domain name. That way, your users, your employees don't see any difference, right? So they still, on their browser, they still type in www.myapplication.example.com, and all the applications are routed here. The second thing verified access does is that it drops a hyperplane ENI from the endpoint to your application VPC. This hyperplane ENI is a point-to-point connectivity service. It's totally AZ redundancy. So from your perspective, you don't have to do any connectivity in the backend to connect the endpoint to your application. So that we take care of it. From your perspective, you just write policies on when a user can access. And many times customers ask that, hey, it is good that you're giving us the flexibility to write per application policy, but I have thousands of applications. Do I really have to write thousands of policy? Is there a simpler way to manage? Yes, there is. Because what you can do is that you can group your applications. So many times applications have similar access criteria, similar security bar. For example, all your productivity applications have a similar criteria. Your IT application, your finance application have similar criteria. So you group them, and you just write a single policy for the entire group. So that's the group policy. And all applications, they inherit this policy, the group policy. In some cases, you might have some application which needs stricter control. They are part of the same group, but they need slightly higher bar. So in that case, you can optionally attach a per application policy. And when the request comes, verified access first runs the group policy, and then it runs the per application policy, in case there is one. If both the policies say yes, then only it connects the request to the application. And we released this feature or this service last year at reInvent, and within 1 year we have released quite a few number of features based on our customer feedback. So this shows our commitment to the space, and this shows that we are working with the customers to innovate in this space. The first thing we did was we integrated with WAF, because our customers said that they want to combine the fine-grained policies of zero trust with broad perimeter, strong perimeter. So now they want to build a strong perimeter and filter out broad internet threats like SQL injection, malware. So that's why we integrated with WAF. Now you can just assign or associate a web ACL to AVA, and all the endpoints, all the traffic coming to that endpoint is filtered through this web ACL. The second thing we did was that many of our customers wanted AVA to pass the identity context, whatever identity we are receiving, right? Like user is from IT department, finance department, user email address, alias, all those things they wanted to pass to the application. So the primary reason was that they wanted to customize the app, because if you open my corporate directory, it is customized for me. So they wanted to use that identity information to customize the app. And from their perspective, they don't have to integrate with the identity system. So they can spare one integration and just directly consume the token from AVA. There's another second use case is that it can be used as a security context, because this HTTP header is signed by AVA. So if your application doesn't receive this signed header, so it means that they received the HTTP request from somewhere else, and then they can drop the HTTP request because it is not vetted by AVA, right? Now, the third thing our customer said that the policies per user fine-grained policy is quite powerful, but in the beginning, in the initial stages, they wanted something which is easy to troubleshoot when they are writing policy, iterating over the policies. So we came up with this feature called enhanced logging, and once you enable this feature, we log each and every request that comes from your identity team, the identity service or the device management service, and keep that with the access record. So in case you want to troubleshoot, you don't have to go and work offline with the identity or device management team. You can directly go to the log, see what data, what signals, what claims AVA received, and then use that information to triangulate your policies. And we went one step ahead. Last week we released this policy assistant feature, which builds on the enhanced logging that I showed. So this is quite cool feature because it allows you to troubleshoot in a graphical way. Here, let's say I went to my IT team and said that, hey, I was not able to access this application, I was able to access last week. So IT team can come to this policy assistant console, they can type my username, they can fill up this filter, and they can say that, hey, I want to see the last access record that was denied for show one to this particular application. Then verified access will pull this information. So on the left side, you will see all the claims that I received from my identity and device posture, which was used for policy evaluation. And on the right hand side, you will see the policy actually here. So you can see like, hey, show one is from HR front desk, and then the policy says HR front desk should be allowed access, so you know it is working. And you can, now you want to make some policy changes. So here you can make the policy changes, you can type the new policy. This is all offline, so this is all simulation, right? And you can simulate what's the effect. So you are saying that, okay, now Chauvin should also have a compliant device from CrowdStrike. So now you can simulate the policy, you can test the policy, see the effect, whether access is allowed or denied based on the data. Once everything is fine, once you are happy, once you have iterated and you are happy, then you can just check in the policy. And some of our customers is saying that it has cut down their policy writing time from days to just a matter of 15 or 20 minutes. So it's quite powerful in that sense. And we also said that we want to build an open ecosystem. So we have simplified the process for onboarding device management partners. The onboarding of identity partners was quite simple because it was SAML or OIDC based, standard based. Now we have simplified the process of device management partners so that they can onboard just within a week. With this new process, we have onboarded Jump Cloud. So they are our third partner in the device space. We already have Jamf and CrowdStrike on the device side. Just to illustrate how Jump Cloud works, here is that all our partners like Jamf or CrowdStrike, they have an agent running on your device which manages the security of the device. Ava has a browser extension which talks to the partner's agent, pulls the information, packs it in HTTP header and sends it to Ava for validating the access. With Jump Cloud, they already have a browser extension, so they have embedded our logic into their browser extension, and they are packing the HTTP header and sending to Ava. The good thing is that if you're a Jump Cloud customer, you don't have to change your browser extension. You can continue using the browser extension. And also their browser extension works on mobile devices. So now you can access your HTTP application from desktop or from mobile device if you're a Jump Cloud customer. So now I will hand it over to Juan, and he's one of our customers. He will talk about their use case and their perspective on verified access. He's a cybersecurity expert, so I'm looking forward to hear from Juan. Thanks.
Hello, everyone. My name is Juan Suarez, and I'm a senior information security analyst at Avalon Healthcare Solutions. Avalon Healthcare Solutions help health plans and lab providers improve care by performing predictive analytics using digitalized lab results. We also help reduce costs by enforcing lab-based policies in real time. We have over 30 customers and growing, managing a total of 38 million members live. As you can see, our health plans trust us with their electronic healthcare records, and we gain this trust by being HITRUST certified year-round. It's a very intense audit for us, over 700 controls. I don't know if anyone's ever been through an audit, very intense, where we get reviewed our process and procedures, our technical controls, and our administrative controls. Avalon is in a unique position to deliver the right test by enforcing policies. We have the ability to gather the data of these digitalized lab results, and we also have the ability to grab the intelligence from these lab results, ultimately being able to give the right care, helping our customers give the right care. You know, when I was putting these slides, I asked Eric Ellis, our enterprise cloud technology president, of why Zero Trust is so important for Avalon. And he said one of our foremost objectives is to optimize the end user experience while steady upholding Zero Trust principles. You know, this quote here really means a lot to me because he, highlights two very important points here: Zero Trust and the end user experience. When we were looking for a solution for remote connectivity, we looked at the security configurations of these remote connectivities. Can we enforce Zero Trust policies and principles in this solution? Are we able to audit this solution? How granular can we get with our, Avalon's and HITRUST requirements for Zero Trust? But at the same time, we look for for the user experience. Ultimately, we want users to be able to be users. And we also look, how long is this going to take for us to implement? We have very limited time and resources, and redesigning infrastructures, creating DMZs, creating access control lists, security groups. When you start messing around with what's already in place and secure, you might introduce risk of misconfigured systems. This is kind of how our infrastructure looked like before we implemented AVA. Kind of a traditional experience. Depending on the type of user that you are, you either get on a VPN client to access web applications or lower environment applications for developers. And if you're a network engineer, you would log into your VPN to manage your firewalls. For a particular use case, our Tableau server contains a lot of PHI data, lab results, and we do a lot of reporting this to our customers. But because we enforce zero trust, sometimes these systems get very siloed in the environment. As you can see, the user will have to log into a workspace to be able to access this resource. This created a very complicated end user experience. When you onboard into Avalon, some users will be like, well, do I need a VPN? Do I need a workspace? Do I need a jump box to access certain resources in our environment? This also created an operational overhead for our engineers. They need to update VPN clients. The workspaces need to be updated, making sure that there's no vulnerabilities living in the workspaces. Just, again, created a lot of overhead work. And because our Tableau server was so siloed in our environment, how do we give access to this to external users? We have to share reports and data to our customers, and our customers are remote. How do we give access to this application without, again, redesigning DMZs and infrastructure? This is where AVA was the solution for us. Our end users now just go into their computers, go into the browser, and they go to the URL that they need to go to. Again, they don't need to log into a VPN, get into a jump box, or go into their workspace. Very simple operations here. Our cloud teams enforces and creates the policies in AWS. And our user's identity also lives in Okta, which is a third-party identity provider. And the IAM team also works with the cloud team to ensure that we uphold zero trust principles. And because our external user's identity already lives in Okta, we have the ability to give them access to our server, or to their data, really, in all the reports. Again, not removing the server where it's at, not putting new infrastructure and creating DMZs. This is kind of how the use case looks like now for the end user that is trying to access the Tableau server. The user will go to the URL. AVA will handle a lot of the policies in there that our infrastructure team built. Is the user authenticated? Is the user authorized? The AVA will redirect them to the IDP and make sure the user authenticates, puts in their MFA, and also checks if the user lives in the correct security groups, have the correct profile attributes, and it's coming from the specified domain that we expect them to come from. If everything checks off, the browser redirects them over to AVA, where, again, the server lives where it was, where we already enforced a lot of zero trust policies in the ACL and IAM aspects. Now, we just didn't stop there. Tableau server also supported OpenID Connect. So we wanted the end user experience to have a single sign-on experience. Just because the user lands in the Tableau server, we didn't want them to just log in with the username and password. So this configuration sends the user, the browser is then sent back to Okta to make sure that the user is authenticated and, again, authorized to log in the single sign-on experience. Now, I do want to highlight that the Tableau server and AVA are both pointing to the same client in Okta in the IDP, but both Tableau and AVA have their unique secret to decrypt the authorization code and the JWT token. We love AVA so much, and our infrastructure and a lot of our systems are very siloed in the data centers that we're going to go ahead and put our SIM technology out in AVA implementation infrastructure. We have FTP UIs that, again, are very siloed that we want to put in front of AVA, ticketing systems that just don't need to be out on the open-end web, where scanners and hackers can exploit these things and potentially cause an incident response. Again, my name is Juan. I'm from Avalon Healthcare Solutions. Thanks for listening to our particular use case.
Thanks, Juan. Thanks for walking us through Avalon's use case. And really a fascinating use case. You simplified your end user's experience while improving your security. So really fascinating. And we just want to wrap up. And we talked about AVA for HTTP access. Then we have EC2 endpoint for SSH and RDP access. Then finally, we have client VPN for network access. So we have built different services for different needs. And please play around with these services. And in case you have questions, do let us know. Me, Tom, and Juan will be hanging around here, so we'll take your questions. And if you like the talk, if you learned something new, please take the survey and let us know your feedback. Thanks a lot.